my name's Morgan.
And I'm Chloe.
And today we're going to be talking about alkenes versus alkynes.
What are alkenes?
So this is an example of an alkene right here. And alkenes are a molecule that consists only of hydrogen and carbon atoms that contain at least one carbon-carbon double bond, as you can see right here.
What are alkynes? An example of an alkyne. Alkynes are similar to alkenes, except these contain one carbon-carbon triple bond.
As we know, alkenes and alkynes are based on chemical bonding patterns and are both unsaturated hydrocarbons. We know that these are unsaturated hydrocarbons because they can both contain at least one double or triple bond.
One thing Morgan and I really struggled with was naming alkenes and alkynes.
We also had trouble connecting alkenes and alkynes. We didn't really know what they were. But if you've ever heard of propane, which is an alkane, then you've definitely heard of propene and propyne. And as we know, propane is used for heating, such as gas fireplaces and barbecues.
A compound with one double bond has the ending "ene," and a compound with one triple bond has the ending "ine," like propene and propyne.
And as I was mentioning, propane, which is an alkane, that has one single bond as opposed to a double or triple bond.
For naming alkenes, the first and most important step is to find and name the parent chain.
The parent chain is the longest continuous chain of carbon atoms that contains the double bond.
We know this is the parent chain because this is the longest chain of carbons that also includes the double bond.
This is the chart that you should be looking at when you're naming a parent chain. For example, if there was 3 carbons, it would be propene. And if there was 6 carbons, it would be hexene.
The important thing to remember is if you have more than 3 carbons in your alkene, you need to make sure to write down position numbers. These are based off of whatever end carbon is closest to the double bond. Like in this case, it's on the right.
And like in the example of the alkene that we were showing you, this is how you're going to name the substituents that are attached to the parent chain.
When you get to the substituents, that's when the position numbers will be super helpful.
Now is when we construct the name of the entire alkene. Now is when we will put the substituents in alphabetical order and specify their position numbers.
This will be followed by the name of the parent chain. So this one is 5-methyl-1-hexene. As we can see, we put the substituent name and its position number first, and then we followed it with the position number and name of the parent chain. Now that we have named alkenes, now we can name alkynes. This is super easy because the only real difference is the parent chain. So we see that this is an alkyne because now it has a triple bond, and the only difference is now instead of hexene, it is now hexyne due to the triple bond. So now we have an example here, and the first thing we do is refer back to our first step, which is naming the parent chain. So now we count the number of carbons. 1, 2, 3, 4.
So now we refer back to our chart and we see that 4 carbons would be butene.
Now we look at our next chart to name our substituent. So the one in our example is CH3, so we look on the chart and see that that is methyl. Finally, we can name the entire alkene by putting the substituent in front. Using the position numbers, we would get 2-methyl, 2-butene.
So in conclusion, naming alkenes and alkynes can seem pretty difficult, but once you break it down into these steps, it can be pretty simple.
I hope this helped you guys understand alkenes and alkynes a little better, and thank you for watching.